Okay, so now we're going to discuss a very common area of student confusion, which is adding and subtracting fractions with unlike denominators. Now, in our previous clip, we discussed how to add and subtract fractions with the same denominator. So hopefully at this stage, our students understand that if we have two fractions whose denominators are unlike, it does not make sense to add those fractions together. So moving forward with that understanding, the question now is, how do we add fractions when the denominators are unlike? We already know how to add them when they're alike. How do we add fractions when the denominators are unlike? So let's just illustrate this with an example, 1/4 plus 1/6. Now, with all of our rules and procedures for adding fractions together, we are again trying to convince students through the use of models and interpretations and the like that the correct rules are the correct rules for reasons. So we're trying to give them reasons why we add fractions the way we do, we multiply fractions the way we do, we divide fractions the way we do, instead of just throwing a procedure at them. So how would we illustrate a 4th plus a 6th? Well, we could start simply by drawing pictures that represent both a 4th and a 6th. Now, I think it is most useful and easiest to draw if we use rectangles to do so. Now, the little caveat here is that when we illustrate our 1/4 and 1/6 with rectangles, we want to do what's so-called opposite subdividing, meaning if we divide our first whole unit, and if we're trying to represent 1/4 and we use horizontal slices as I did here, and maybe we would again shade one unit. So this clearly represents 1/4. If we use horizontal slices here, let's just make sure to use vertical slices with our other fraction, which is in this case 1/6. Okay, so we have 1/4 and 1/6, and now we're at a point again where students will at least understand where we are so far because they have a lot of experience representing fractions using pictures. Okay, now hopefully again at this stage, your students will recognize through the picture that it does not make sense to add these fractions together because the pieces are of different sizes, right? This piece, this horizontal piece, is just a different size than this vertical piece. Okay? We couple this with the students understanding at this point that if the pieces were the same size, then we would know how to add the fractions together because students at this point know how to add and subtract fractions when the denominators are equal. So now the question becomes, what can I do to these pictures to ensure that the pieces are going to have the same size? And what I can do is just do the exact opposite subdividing on each picture. And what I mean by that is, originally, I started by chopping this into 4 kind of horizontal pieces and chopping this rectangle into 6 vertical pieces. So now I'm just going to do the exact opposite. Now I'm going to chop my first diagram into 6 vertical pieces. And I'm going to chop my second diagram into 4 horizontal pieces. The end result of doing this ensures that the pieces that I have in each picture are exactly the same size, even though my drawing's not 100% accurate. The pieces are exactly the same size, right? Because in the long run, I ended up doing the exact same thing to both rectangles. I chopped both rectangles. They're indistinguishable now, right? What I did was 2 stages on each rectangle. I chopped into 4 horizontal pieces and 6 vertical pieces, and I did the same thing on both. So what that means is the pieces are now exactly the same size, and your students are going to recognize, now that the pieces are the same size, they can add the fractions together. Now, arithmetically, what happened when we chopped the second time? Well, as we saw in our last clip, chopping the second time renames the original fraction, right? Because if we started, this fraction started as 1/4, so it started as 4 horizontal pieces. But if we then chopped into 6 vertical pieces, the effect that has is multiplying the total number of pieces by 6. The total number of pieces that make the whole, again, is the fractional unit, so that's your denominator. And it also multiplies the number of shaded pieces by 6. So what this does is, in effect, it renames this fraction by multiplying 1/4 by 6 over 6, or 1, and it renames this fraction 6/24. On the other hand, we originally started with 1/6, which was 6 vertical pieces, 1 shaded. We then cut those pieces into 4 horizontal pieces. Cutting into 4 horizontal pieces had the effect of multiplying the total number of units of pieces, fractional units, by 4, and also multiplying the number of shaded pieces by 4. So what that does is, in effect, it renames the fraction 1/6 by multiplying by 4 over 4, and it renames this fraction 4/24. Your students now are going to recognize that since the pieces in the diagrams are exactly the same size, and the denominators of your fractions are exactly the same, now they can add. And at this point, students know how to handle 6/24 plus 4/24. They know to add across the numerators and get an answer of 10/24. Okay? Now, one thing you may notice here is that the use of lowest common denominators and least common multiples is not used anywhere. Okay? Remember what we're trying to do. We're trying to make this process a convincing one to students. So if we go through this process from a student's perspective, if they originally see 1/4 plus 1/6, they realize that it does not make sense to add those fractions because the denominators are different. So the next thing we have to realize is, well, I don't know how to add fractions when the denominators are different. I do know how to add fractions when the denominators are the same, so somehow I need to rewrite 1/4 and 1/6 so that they have the same denominator, what we refer to as a common denominator. Okay? But at this point, it's not immediately apparent how we find a common denominator. Okay? Now, what this illustration shows us is that a common multiple of the denominators, and namely, in this case, just the product of the denominators, makes sense. If we use the product of the two denominators as our common denominator, that makes sense, because in doing so, the pieces of our diagrams are exactly the same size. It makes sense to use the product of the denominators in this picture. It doesn't make sense through this picture to use the least common denominator. Okay, so we shouldn't force the least common denominator on our students. Okay? What we will recognize, however, is that eventually students are not going to use models to add fractions. In fact, they're really never going to use models to add fractions. The models are used to motivate the correct technique for adding fractions together. And once the correct technique is learned, then there's no need for models anymore. So once students are practicing adding fractions, using the fact that a common denominator can be found by just taking the product of the individual denominators, then a teacher can point out, after they have become proficient at these types of computations, that other common denominators can be used as well. We don't just have to use the product of the denominators, we can actually use the least common multiple of the denominators. But that should not be forced on students, and the process should be explained using the product of the denominators. Keep in mind also that even though we illustrated an example that used addition, we could easily change this sign to a subtraction sign, and the same idea applies. It doesn't make sense to subtract fractions if they have different denominators. So we could draw the same pictures. We could envision taking 4 pieces away from 6 here to see that 1/4 minus 1/6 is going to be 6/24 minus 4/24, which is 2/24.